22 in section 1.5, and let's read it together. An athlete whose event is a shot put. Shot put release. I'm not sure what the. I'm assuming it's a.
You throw the.
You throw. Okay. Sorry about that. I'm not familiar with that. Releases the shot. Fine. When the shot is released at an angle of 20 degrees, fine. Its path can be modeled by the formula. So it's something like I throw this pen in the air, up and out, right? So it follows. Look at it one more time. What type of function would this be? The trajectory is exactly what type? Quadratic. Here it is. This is a quadratic function. So it either looks like this, or possibly looks like this, or possibly looks like this. I don't know. We haven't graphed that. In which x is the shot's horizontal distance. So this is x. Or this is x. How far from the launching spot the shot hit the ground. Okay. In feet, of course, and y is the height in feet. So this is y, and this is x. Okay. This formula is shown by one of the graphs, A or B. We haven't discussed which one yet. Use the formula to answer the questions below. Use the formula to determine the shot's maximum distance. Okay, so the maximum distance is approximately run to which graph shows the path such and such. Okay, now this, they assume now in 1.5, which are in chapter 2, I'm not going to assume this, but they assume that we know how to determine the maximum of a quadratic function. So the maximum of a quadratic function is determined by finding the x where the maximum is with the formula negative b over 2a. Where does this come from? Does anyone remember the quadratic formula that we studied last week? Yes, I know you do. So this is negative b plus or minus the square root of b squared minus 4ac over 2a. And you can say, why do you need this here? Here's why. Because I want you to determine, to remember that the x-coordinate of the maximum or minimum, in this case it's a maximum, called vertex, is this. That's why I put it up here. Okay? So the x-coordinate of the vertex will be negative b over 2a. Let's calculate it. So that's one way. That I strongly recommend. Okay, so let's find, can anyone give us A, B, and C? Can anyone identify A, B, and C here? We have to take the number with the sign in front, mandatory. So the number A, part A, or leading coefficient is this. Middle coefficient is 0.4. And the free terms, the so-called free term, because it's free of variables, is 6.3. So we want to determine negative b over 2a. We copy the negative sign. We copy b divided by 2 times a, which is negative 0.02. When I divide a negative by a negative, or I have two negatives in here, what will the sign be? Of course, right? I can't say that the distance between me and you is negative 5 feet, right? So if I throw a ball or whatever, a shot, it has to be a positive x. So it's 0.4. Let's multiply the top by 100. Let's multiply the denominator by 100. So I get that x is 20 feet, to make sure. So this is 20. But how do I determine that maximum? So I have the x, the distance between where I'm standing and where the maximum will be. The the distance between me and where the maximum is. So if the maximum is here, the distance between me and x that creates the maximum is 20 feet. Okay, so now how do I determine that maximum? Don't worry about this if you have any difficulties with this. Well, I'm going to go back on in chapter 2 and do it from scratch again. Okay, so then how do I determine this value? Excellent, of course. So this must be f of 20, or y when x is 20. So f of 20 will be negative 0.01 times 20 squared plus 0.4 times 20 and plus 6.3. I would use my calculator for that. Here it is. I hope you're proud of me. I'm ready. Okay, times 400 because that's what 20 squared is, and plus 0.4 and times 20, and finally plus 6.3. And I hit enter, and I get 10.3 feet as well. So then this is 10.3, and the height is 10. The distance, very careful, always read the fine print. Round to the nearest tenth as needed. There is no need. This is exactly 10.3. And then which graph part A or B shows the path, shows the shot's path? I don't know. I have to see. They say 0 to 160, meaning here's the viewing window. Here is 0 and here's 160. And with a tick of 20, okay, 20, 20, 20, 20, 20, and so on and so forth. And this is 0 to 20, 0 to 20 with 5. 10, 15, I'm sorry, 5, 10, 15, 20. So the at 20, which is here, because we are told that it's welcome. So it's 20, right? The height will be 10.3. So this is 10, so this is 10.3. If that's the case, 6.3 will be here. So this will be the graph. I don't know how far it goes. I didn't calculate. But this is definitely 20, comma 10.3. This is the maximum, 20, comma 10.3, the vertex. So the vertex here, I don't even see it. So it could be this at 0. I'm not sure what is the maximum. But definitely we found the graph that we need as being A, not B, right? We can also determine the x-intercept. Let's find the x-intercept to see where this falls. I see here 20, 40, 60. So it's somewhere between 40 and 60. Definitely above 50. So let's find the x-intercept to further convince ourselves that A is indeed the correct graph. Today is still the 3rd. So one more time, y equals negative 0.01 x squared plus 0.4x plus 6.3. How will I find the x-intercept? It's a very good question, very good problem. Thank you for bringing it up. How do I find the x-intercept or intercept? For any function. Forever. What do I do to determine the x-intercepts for any function? I know you know. You just have to have the courage to say something. Excellent, thank you. Negative 0.01 x squared plus 0.4x plus 6.3 equals 0. So for the x-intercept, make y equal 0. For the y-intercept, what do I need to do? Very good. So again, in your little notebook, if you forgot, I would write the x-intercept I determine blah, blah, blah. The y-intercept I determine blah, blah, blah. And review that as often as needed. Good. So now, of course, I don't like to use decimal numbers, and never, ever I will solve a quadratic equation with a negative leading coefficient. That's my policy. You do not have to have the same policy. But obviously, I see one digit, one decimal digit, one decimal digit, but two decimal digits. So I will multiply by negative 100 to clear all decimals. Do I have to? No. Do I have to change the negative leading coefficient into positive? No, but it will be much easier if I do. So this is x squared minus 40x and minus 630 equals 0, which I find easier to work with, but that's me. So this times negative 100 is 1. 0.4 times negative 100 is negative 40. 6.3 times negative 100 is negative 630. Of course, I only have one option here, which is quadratic formula. Negative b plus or minus b squared minus 4 times 1 times this. Since this is a negative number, I will do this over 2 times a. Why? Because I don't want parentheses, nested parentheses, inside parentheses, etc., etc. Okay, so let's do this together. So parentheses, remember, around the top, 40 plus the square root. The software may not require parentheses under the square root, but I don't care. I put them in there. 40 squared, and then plus 4 times 630. Close the parenthesis under the square root, go outside of the square root, close the parenthesis, and then divide by, what was it, 2. In order to determine the other one, I will just copy the whole thing. It's easier for you than it is for me with the software. And just overwrite the plus in front of the square root by a minus. Right here. And then I get the other one. Of course, I don't care for a negative distance, because I do this, but the entire function crosses the x-axis twice. So that's okay. But I don't care about the negative one. So I go back. So the graph is like this. I'll go back to the graph in a second. And we know that this is at 20. We know that the vertex is at 10.3. We know that the height here is at 6.3 because when I make x equals 0, when x is 0, y is 6.3. And I determined that there are two options. X equals 52.09 and x equals negative 12.09. Negative 12.09 is this. No one cares about it. So this is 52.09, and this is exactly what we're expecting. Because 20, 40, 60. This is way out there, right? If this is 160, this is 140 and 120. There's no way B is the graph. But A was an excellent problem. We were not having this information yet. I don't assume that you remember this, so I'm going to show it again in chapter 2. But is this clear?
That's not how the book showed it. The book wanted us to use the decimals and everything in the quadratic formula. This is a lot easier.
Oh, you mean to solve this?
Yeah, they wanted us to plug that into the quadratic formula.
No, I don't. Will you get the same answer? Of course you will. But always two key words I want you to, if you don't learn anything else from me, I want you to remember these two key words. These are key words in anything that pertains to math. Always try to simplify what you're doing, what you're solving. If you're solving an equation, if you're solving an inequality, always try to simplify it first. And that's what I did. Because I know some of my weaknesses. I know I don't know all of them. But one of them is having the negative in here in the denominator, having the negative 0.01 times 2, negative 0.02, if I omit to put parentheses around that, if I don't simplify it like this, I mess up the whole problem. Because the calculator doesn't know what to do if I don't tell it step by step what to do. So this times 2 would have been here, negative 0.02. And if you don't put parentheses around that, you'll get a totally different answer than the one that is correct. So I always try to simplify and get rid of the negative leading coefficient, always. I always do that. And secondly, I don't want decimal numbers in there. What if I just don't type the dot? Who knows? And then it takes me like forever to find my mistake. Okay, perfect. Other questions for me? Very good question. Thank you. Anything else before we go back to 1.6? I meant to do a word problem, but since we did this one, it's awesome. That's perfect. It saved me time. And I didn't have to choose. Somebody already chose for me. I like that. I'm lazy when it comes to choosing. I'm kidding. I'm kidding. Okay, ready? Okay, so let's see what we know about equations so far. We know linear. We know quadratic. We know rational. We know polynomial. And we know radical. We're going to learn more today, and then hopefully move on. I put the heat or the thermostat on max warm, and I know it's cold, so I'm sorry. I don't know what's happening. Okay. Any questions about these equations? Would you like me to go back to any of this, of any example or anything, or we move on? We move on? At any point in time, if you remember something, we can still go back to any of this. Okay. The next type of equation is equations, quadratic, and you should say not again. No, no, no. In form. Okay, you can say, is it quadratic or not? What do you mean? So my answer is this. These equations, deep down at the core, in their heart, they are quadratic. But actually, they're not quadratic. But they can be replaced by a quadratic equation. I know it sounds confusing. Let me start with an example. 42 on page 185. In which we have x to the fourth minus 13x squared plus 36 equals 0. When you look at this equation, obviously you'll say, oh, it's polynomial. Oh, it's degree 4. Yeah, you're going to find 4 solutions. True. But I really don't know how to solve this. Because normally polynomials should have 4 terms, so I can factor by grouping. But here I don't have 4 terms. Okay, I only have 3. So then, what is the method that we're going to apply here? Only, and it works only if the equation is quadratic at its core, in form. Deep down, it's basically quadratic. We're going to look at x squared, and we're going to look at x to the fourth. And I'm going to ask you a silly question, and I do that a lot. Which power is lower? Good, indeed. So I'm going to say give me any letter but x. Any letter you can think of.
M.
M it is. I'm going to let m be x squared. So I'm going to, don't erase anything, I'm just making a point. So I'm going to replace this by m. But I can have x and m in the same problem. I make it 10 times more difficult, maybe impossible. But is there anything that I could replace this by in terms of m? Of course. So that's why we call this equation not quadratic, but quadratic at its heart Because it can be replaced by a quadratic if I use a particular substitution. This is called substitution. I substituted x squared for m. Why? To make my life easier. Because now this, I can easily factor and find the solutions in m. But you could say, who cares about your m? No one. The solutions have to be in x. In a moment, we'll get to x. Also, I would like to write what I said at the beginning. Can anyone tell us again what is the degree of this polynomial? How many solutions do we have to find? Absolutely 4. Perfect. So then can anyone tell us how to factor the m squared minus 13m plus 36? Every time you make me wait, my markers are drying out, and you're going to pay a cent. My markers are drying out. Okay. I'm kidding. Nobody's paying anyone anything. Just kidding. So how do we factor this? Of course. Very good. So m minus 9 and m minus 4. Very good. And the options for m then, awesome. Excellent. But m equals 9 is an equation. And m equals 4 is a different equation. Now please tell me what you will replace this by. What equation is this? Of course, I have to go back to the substitution. M is x squared. Exactly. Awesome. Now remember those 4 methods that we talked about solving quadratic equations? One in specifically, one in particular is the best for this. Which one out of those 4? The markers are drying out. Thank you very much. Remember, okay, so then
3.
if I write 3 is wrong. Thank you. And x equals? That's it. That's how we get those 4 solutions. Great job. Let's look at another application of this, another equation in which we will use a substitution. Now you can say, and I do have students almost every semester telling me, I don't want to use your substitution. I don't care for it. I can easily factor this into x squared minus 9 times x squared minus 4. Awesome. Great. That's fine. You don't have to use a substitution. The substitution simplifies our lives, however. So from here, you realize that if this is t squared, you change it into this equation, you solve for t or m, whatever, and then you get the x solutions in x. It's up to you. If you see how to factor in this case, you don't have to use a substitution. I will not indicate use a substitution. If you can solve in another way, that's fine. Okay, so here's another example, like let's say 57 caught my eye on page 185. Okay, so I'm looking at x squared minus x, everything squared, minus 14 in parentheses x squared minus x plus 24 equals 0. Can you solve this in another way without the substitution? Of course. But it will take you longer, I think. because you have to square. You're going to get a polynomial degree. When you square x squared, what degree will you get? When we square x squared? 4. Yeah. So you have to square that. You have to combine like terms. You have to potentially maybe factor by grouping. I don't know what it's coming up with. So it may be much longer and maybe even difficult. I don't know. So, but let's notice something. Just look at it, don't do anything. Just look at this equation. And of course, we know it eventually, if we expand, it has degree 4. And we have to find 4 solutions. This is carved in stone. Even if our solutions are all the same, I still have to find 4. Okay, so then just look at this and say, I see, without the I see. But just say, I could use a substitution to make my life easier. And which substitution will you use, and which letter will you use? It doesn't matter, any letter but X.
S.
I can use X. If X is in the
S.
S, very good. The markers are drying up. I deduct 1 point from everyone's test when my markers, and I'm kidding. So, can anyone say anything?
You want S to equal X.
Then it's not going to make any difference.
X squared.
Then it's not going to make, that's not going to be possible. Indeed, we want this. And then what is this? What will this be replaced by?
S squared.
That's it. That's the idea. The idea is that I eliminate X and I replace the equation with a simpler form of that same equation, but a simpler form, because at its core, it's quadratic. Can anyone dictate the new equation?
S squared minus 14s plus 24.
Excellent. This is more human. And then, how do I factor this? And then I get 2 options for S. So S squared minus 14S plus 24 would be right. Sum is negative 14 and the product is 24. Of course. Very good. Thank you. So then the first one is, it doesn't matter. The order, it's up to you. 2 and 12. But that's not sufficient, right? I know that the equation S equals 2 and the equation S equals 12 really mean something else. What do they mean? The first one means
X squared minus X equals 2.
and the second one,
X squared minus X equals 12.
excellent. Although we're not done, those two should not create any problems. Because the first one is X squared minus X minus 2 equals 0. The other one is this. And I should have no difficulties in factoring. If I have difficulties with factoring, then I should use the quadratic formula. No one is asking me to do one or the other, to apply one method or the other. Doesn't matter. How do we factor the first one?
X plus 2, X minus 1.
It has to be minus 2. S minus 2 and S plus 1. Probably, if that's what you said, my apologies. Is that what you said?
No, I flipped it.
That's okay. Because remember why? The sum has to be negative 1. If this is positive, then whatever. It's not going to work, but still. But I have to have a negative 1 as the sum. And the other one? Yes, X minus 4 and X minus 3. So, sorry. It's x, right? So then can anyone give us those, how many solutions we expected?
4,
Good. Can anyone give them in any order? I don't care.
2, -1, 4, 3.
Here they are. So it's a useful, interesting, I would say, maybe, if you find it interesting, I hope, a method of substitution, but it only works for equations that are at their core. Yes, any question?
Is 3 or 4?
Oh yeah, it's positive. It's positive. Yes, 3 is positive. Sorry. Of course. Because the sum is -1. Thank you. My apologies. Sorry. That's what you said, but I didn't write it. So it is x minus 4 times x plus 3. Therefore, the fourth solution is x equals -3. Is that clear? Sorry. So you're using a substitution only when it's applicable, right? So if it's not applicable, and I'll show you an example just to discuss it, it's not applicable, then it's not applicable. So for example, if I have the same thing, but I have x cubed, previous problem, minus 13x squared plus 36 equals 0, this is not quadratic in form. Because if I replace this by t, I cannot replace this by t squared. When I squared x squared, I will never get x cubed. So this is not quadratic in form. I can solve it with the same method because it's not applicable. The method is not applicable here. Any questions? Any questions? We have two more types of equations to look at. One is called equations with fractional exponents. Again, this is not a user-friendly type of equation. So let me start with an example. I recommend my method over this method. Of course, I accept it. Let me just show you the method. I don't even talk about it. It's this. Solving radical equations of the form x raised to a fractional exponent equals k. I don't recommend this. We can go step by step around this and we don't have to memorize it. So I recommend this method. If you read the book and you understand it, or somebody in the math lab explains this to you, it's fine. And you understand it, use it, please. Okay. Let's start with 33. Same page, 185. X minus 4, everything to 3/2 equals 27. Again, there is some overlap, right? I showed you two polynomial equations 5 minutes ago. But they were actually quadratic in form. But they were still polynomial equations. Same thing here. This is an overlap with radical equations. Any exponent that is a fraction is a radical, right? We don't have to think in those terms, however. What I recommend is, in step 1, eliminate the denominator. Eliminate the denominator. How would I eliminate the denominator? What should I do to both sides to eliminate that denominator of 3/2? Exactly. Thank you. I have to square both sides to eliminate this. This power will eliminate the fraction, the denominator and the fraction. Awesome. So, we have x minus 4 to the 3rd power because I copy the base and multiply the exponents. And when I multiply the exponents, I get 3. Equals 27 squared. 27 squared equals, I got 729. Okay, so I eliminated the fraction. That is the denominator. That is the first step. In step 2, now eliminate. Yes. If you always in these situations you follow these 2 steps, you will not have to memorize anything other than the steps. The first one, eliminate the denominator. The second one, second step, eliminate the power. You will not have to analyze anything. You're not going to have to split hairs. But that's my opinion. It's up to you. So how do I eliminate the power, which is power 3?
That's what it's called.
The cube root. Excellent. The cube root indeed. So then the left-hand side is x minus 4. And the right-hand side, here's how you put it in. One option will be, these more sophisticated calculators, they have the cube root. It's right here. So you put the cube root and then 729, and you just press enter. I never use this. I prefer 729 power in parentheses 1/3, because I know the cube root is power 1/3. So I never have to go to that menu. And when I press enter, I have to get 9. If I have power or the 5th root, then I have 1/5. I raise it to 1/5. If I have 2/3, I raise it to 2/3. Oh yes, of course. Absolutely. So that's what I recommend. So then x minus 4 equals 9. The cube root of 729 is 9. And then x equals 13. Because we squared both sides, we have to go back and check. If you remember from radical equations, always go back and check when you raise both sides to a power. So here was the answer. I got x minus 4 when I took the cube root of this, and when I took the cube root of this, I got 9. I added 4 to both sides to get x equals 13, and this is a question mark now. With x minus 4 to 3/2, does this equal 27 when I replace x by 13? Of course, because it's cubed. Because I squared, so maybe not. Of course, it will work, but let me show you how you do this. In parentheses, you don't even have to simplify, but if you want to, it's just 9 raised to, oops, I didn't mean that. 9 raised to, in parentheses, 3 divided by 2. And when I hit enter, I should get 27. If I don't get 27, and I'm in trouble, or I have to go back and say, oh, well, no solutions, whatever. So this is one example of equations. Steve, you needed more time?
No, you're good, ma'am. Thank you.
So this is an example of equations with rational exponents. So I'd like to look at another one. Why not? Let's say 38. Any questions for me? Please always stop me. I don't want to just move on. Everything okay so far? Okay, here it is. It's x plus 5. Everything to 2/3 equals 4. So that formula that you see in the book that I showed you, so here's the difference. Let me caution you. 3 is an odd number. 2 is an even number. So the denominator was even and the numerator was odd. Now this is reversed. The numerator is even and the denominator is odd. Okay, so let's see what we do. According to our method, if you prefer what I showed you, what will you get rid of first? The denominator. What does that mean? What do I have to do to both sides in order to get rid of this? Yes, of course. Do you all agree with cubing both sides? Okay, the left-hand side then is x plus 5, everything
Square.
excellent. And here I have 4 times 4 is 16. 16 times 4 is 64. Now I'm going back to one of the very important methods out of the 4 methods of solving quadratic equations. What do I do?
Square both sides.
Careful. Close. We do what? Exactly. We take the square root, we apply the square root, or we take the square root. How many solutions will you find now? Indeed, x plus 5 equals. Indeed, thank you very much. So then x equals -5 plus or minus 8, and I have to separate them. So tell me what you get when you separate them, which was not the situation before. So careful with that. Before,
Is it
yes?
3?
Yes, it is positive 3, negative 5 plus 8, and
Negative 13.
perfect. Yes, and negative 13. Let's go back and plug them in. Here's the original problem. X minus 4 raised to 3 halves equals, no, I'm copying the previous problem, sorry. X plus 5 raised to 2/3 equals 4. So we replace x by 3. What do we get? I don't want to confuse you when I post this, so that's why I have to get it out of here. Sorry about that. Okay, so then, how much is 3 plus 5? So I have to take 8 to 2/3. Let's take 8 to 2/3 and see if we get 4. So 8 caret in parentheses 2 divided by 3. If I don't get 4, 3 has no place here. I got 4. Okay, the second one, so I accept x equals 3. I'll say yes. Now, negative 13 plus 5 is negative 8. Awesome. So let's do now negative 8 raised to 2/3. So in parentheses, negative 8 power in parentheses 2 divided by 3. If the answer is not, if it's not 4, what will I say? Does this work? No, but it will be. So in this case, both solutions work. Be very careful with parentheses. Any error in parentheses does not give you the correct answer. Very careful. And that's how we solve equations that have fractional exponents. Not an easy situation. The last one is much easier, but let's talk about it. Absolute value equations. And that's it for now when it comes to equations. Okay, so let's start with a simple situation, and then we'll look at other examples. Let's say the absolute value of x equals 10. What does this say? It really says find x values such that x is 10 units away from what? Such that as x is 10 units away from 0. Let me rephrase it. Find x value such that the distance, I prefer that. The distance between x and 0 is 10 units. I prefer that. That the distance between x and 0 is 10 units. I prefer that. Although the other one is not incorrect, but I prefer this. So let's find x such that the distance between x that you give me and 0 is 10 units. What do you think? Which numbers are to be or are found 10 units away from 0? Very good. Thank you very much. Indeed. X equals 10, x equals negative 10. Now, what if I have the absolute value of x equals negative 3? So these are the solutions here. What will you say about this? I'm telling you the distance is negative 3 units. What will you say?
X equal 3, X equal 3.
No matter what you put in here, the distance will never be negative 3.
Because any value is
Always part, unless there is a minus in front, which is a different story. Perfect. What about this? How many solutions will this equation have? Just x equals 0. Very good. So you see 2 solutions, no solutions, 1 solution. There is a fourth one with infinitely many solutions. For example, the absolute value of x minus 1 equals the absolute value of 1 minus x. But I have not seen an example like this, so you do not have to worry about that. I didn't see an example like this in your book, so we're fine. So just keep in mind that absolute value equations can really, really come up with all sorts of stuff. 2, 1, 1, 0, infinite. Okay, so let's look at a couple of examples from your book. On page 186, 68. And we have 3 times the absolute value of 2x minus 1 equals 21. I specifically picked this problem. Let me see where I'm with my video. 1 second. Yeah. So here's what I'm doing, so you don't think that